All right, so the next one says that a salary is growing linearly and is given by this, where t is measured in years. Well, the slope is right here, 2000. So that's the slope. And what does it mean? It means that with every increase in time, with each year, the salary is increasing by 2000 because it's positive. The slope is positive. So we would say the slope is 2000, and interpretation with each year, the salary is increasing by $2,000. Now we have that the salary is growing exponentially by this, where t is measured in this. Identify the growth rate as a percentage. So this is the growth factor right here. So A, the growth factor is 1.05. The growth rate is going to be 1.05 minus 1, which is 0.05. And 0.05 in a percentage is 5%. So this is 5%. Interpretation with each year, the salary increases by 5% of the previous year. Now use a calculator to graph these two functions. Sketch the graph on the plane below. Make sure you plot the y-intercept for each function. So this is the salary and this is the time. We know that the first one is a linear function with y-intercept 40,000. So the line will start here, and then let's see another point. Let's see what is another point, 16. When t is 16, the amount at 16, so after 16 years, your salary would be 40,000 plus 2,000 times 16. So if we put that in the calculator, we would get 40,000 plus 2,000 times 16, 72,000. So somewhere here. So at 16, we would have it somewhere here. So this one is A of t, so that's the linear growth, and then the exponential growth starts at 35,000, so it starts a little lower in between right here. But let's see, where is it? Where is the exponential after 16? So P of 16 will be 35,000 times 1.05 to the 16. Put that in your calculator. And you'll see it's 76,400. So 75, 76 will be right here. So this is gonna be like that. That's your PT. Use the intersect feature of your calculator to get the intersection point. So basically the intersection point is gonna be right here. So let's see exactly what it is. So what I'm gonna do now is bring up the calculators. And in y1, I'm going to put the first function, which was 40,000 plus 2,000 t. Well, I have x, not t in there. And then the exponential is 35,000 times 1.05 to the power x. And now let's pick the window the same as what this graph is. So the x goes from 0 to 20, and then the y goes from 0 to 90,000. 1, 2, 3. And then in the hit graph, you see the line, that's A of t, and then P of t is the exponential growth. And to get the intersection point, we are going to go to second calc, and we're going to pick intersect. First curve is one of them and the second curve is the other one, and then if I press enter again, I would get that the intersection point happens after 13 years, and it's almost 66,000. So then we would say that the intersection point, label it 13 and then 66,000. Okay. All right, let's do the next one. A substance currently consists of 2320 grams and it grows at a rate 15% per day. So create a model that represents the substance after X days. So the model is going to be Y equals CA to the X, right? So let's plug in. What is C? C is 2320, the initial amount, and then it grows at 15. So the rate is 0.15. What would be the factor? It would be 1 plus 0.15, which is 1.15. So times 1.15 to the X. So this is what it would go in here. This is the model. Now it says how many grams of the substance are present after 3 days. I basically plug in 3 for X, 1.15 to the third, right? 3 days means 3 right here. So if we put that in the calculator, we get 3528. Round to the nearest gram, so it'll be 3528.4, so it stays 8. How many grams of the substance are present after 1 week? Well, X is measured in days, so 1 week means 7 days, so this will be the same, but X is 7 now. So when I change the 3 into a 7, I get 6171 grams. Okay, so we just have to pay attention. Now determine the number of days it will take for the substance to reach 9500. So basically now I have that Y is 9500 and it started with 2320 and then 1.15 to the X. So I need to solve for X because that's what it means, the number of days. So I need to solve X equals what when the Y equals 9500. So we got to solve for this. So I'm going to divide both sides by 2320. So it will be 9500 divided by 2320 equals 1.15 to the X. My unknown, what I'm solving for, is an exponent. So in order to bring it down, remember we have to apply log of both sides. So let's do apply log base 10. Log. Okay, so now the exponent comes down in front. So my equation is going to turn into log of 9500 over 2320 equals X times log of 1.15. So to solve for X now, I'm going to divide by log of 1.15, both sides. And that will give me the exact form as X equals log of 9500 divided by 2320 divided by log of 1.15. So this is the exact form. You leave the logs as they are. You don't approximate anything. That's the exact form. The rounded form is when you would put this in the calculator. So now you would put this in the calculator. Log of 9500 divided by 2320 and then everything divided by log of 1.15. This is just a number. It's 10.09. So 10.09 what is it, days. So it takes that many days for the substance to reach 9500. Oops. How long does it take for the substance to double? Well, if I started with 2320, to double it means 2 times 2320, right? So I start with 2320 and I want to see when the Y is twice that. So this is the same solving for X. So we're going to apply exactly the same approach. So we're going to divide by 2300. So I'm going to get 2 equals 1.15 to the x, and then I'm going to apply log. So then x is going to be, x is going to come down in front, so it's going to be log 2 equals x times log 1.15. So x is going to be log 2 over log 1.15. That's the exact answer, and if we wanted to round it, we're just going to put log 2 divided by log 1.15. Let's just say 5 years, approximately 5 days. All right, next problem, it says a substance currently consists of C grams and it grows continuous with a rate of 9.5. So this is your cue that you need to use the E one, the Y equals C times e to the kt. So y equals, it doesn't tell you what C is, so you have to leave it at C, e to the continuous rate of 9.5, so the k is 9.5% in a decimal, which is 0.095 t. So that is my model, y equals C times e to the 0.095 t. Now determine the number of years, so we need to find t such that the substance triples its amount. So now I want to find, so I'm starting with C, and I'm interested to find the time t. I'm interested to find t such that here I have triple what I started with. Well, if I started with C, triple C is going to be 3 times C. Okay, so now I divide both sides by C, and I'll get that 3 equals e to the 0.095 t. And then I take ln in this case of both sides, and I will get that ln of 3 equals 0.095 t. And then if I divide both sides by 0.095, I get that time equals ln of 3 over 0.095. So this is the exact answer. To get the approximation, I'm going to put that in the calculator. So ln of 3 divided by 0.095, 11.56. So 11.56. So this is, it takes 11.56 years for this substance to triple an amount. So I don't know what it started with, but it takes that many years for it to triple what it started with. Okay, now determine the number of years it will take for the substance to grow by 75% of its current amount. So now I'm interested to grow by 75%. It means that if you start with C, you're interested to see when you have the C plus 75%. So it's C plus 75% of C. Right? So that will give you actually 1.75 times C. So the point right here is like 1 point C, 1 of C plus an additional 75% of it. So this is what I need. I needed to set it equal to 1.75 C equals C e to the 0.095 t. Dividing by C both time, I get 1.75 equals e to the 0.095 t. And then taking ln of both sides, I get, let's continue in here, I get that t equals ln of 1.75 divided by 0.095, and this gives me t equals 5.89 years. 5.89 years. So again, I don't know what I started with C, but I know it's going to take 5.89 years for that C to grow by 75%. Now it says that after 11 years, so that means when t is 11, there's that many grams remaining. So the equation is going to be 346. That's how much I'm going to have, equals C times e to the 0.095 times t, but t is 11. Okay, so basically I can solve for C now. This is just a number right here. This is just a number. You can put it in the calculator and get it. So to solve for C, I'm going to divide by that number times 11, both sides. So then C equals 346 divided by e to the 0.095 times 11. So let's put that in the calculator. 346 divided by e to the power 0.095 times 11. 121.69 grams. Alright, so in this case, so if I wait 11 years and I see that there are 346 grams left, then we must have started with the initial amount as being 121.69. Alright, last question. It says that this is a homework question. So this one says that you have no more than 70,000 and you need to invest in 2 investments, high risk, high yield, and low risk, low yield. At least 10,000 is to be placed in the high risk. So basically x plus y has to be less than or equal to 70,000 because you don't have more than 70,000 to invest. So if you invest x at high risk and y at low risk, whatever together it is, it has to be less than or equal to 70,000. It says at least 10,000 is to be placed in high risk. So x has to be greater than or equal to 10,000. So this one is out of the question. So now I have, because both of these have that. Now the next thing, it says furthermore the amount invested at low risk, which is y, should be at least 2 times the amount invested at high risk. So this says that y is greater than at least, it's greater than 2x. So the answer will be C. And then if you graph these, you'll see that the answer is going to be greater than, it's between A and C. Y is greater than or equal to 2x. So how you can do this, you can pick a point in here, or no, just so this one is out of the question because x is greater than or equal to 10,000. I think that's the answer.